Hello gems, welcome back to another video. So today is episode 2 of our question bank series for BITSAT 2025. We are discussing the chapter motion in one dimension. In the previous episode we discussed the chapter units and dimensions. So if you are interested in that, do check out the previous video. You'll get to know a lot about this series and how it will help you for BITSAT 2025. Okay, so with that being said, let's begin with today's video. Okay, so the first thing that we do in this series is discuss the topic wise weightage in a particular chapter so that we know the most important aspect of that particular chapter as far as BITSAT is concerned, right? So we'll go through the topic wise weightage, topic wise previous year question weightage. Okay, so from average speed, average velocity, that topic, the first topic, we have 2 questions being asked in the previous year. Then we have also uniformly accelerated motion, only 1 question from there. Now motion under gravity is also one of the examples of uniformly accelerated motion. Only A is minus G in the particular case of motion under gravity, but I've kept it separately because it's one of the most important topic for BITSAT. Okay, so a ball being dropped from the top of a tower or from a hot air balloon, so on. Questions can be framed, right? We'll look into the questions in a while. So motion under gravity, 6 questions were asked from that particular topic. And we also have non-uniformly accelerated motion, so you'll have to use the differential form, right? A is equal to dv by dt, x is equal to x, no as such formula, but yeah, v is equal to dx by dt. So you'll have to use the differential form, that is non-uniformly accelerated motion. Okay, we'll come to the questions. Then we'll also have relative motion between 2 objects. Okay, so suppose an observer or a subject wants to catch a bus, right? The bus is also in motion, he has to chase down the bus, there is some initial distance, so you can work out, right? So that is relative motion. Then finally questions from graph. Okay, you might be given a graph and then asked to interpret it. Okay, is it for uniform motion, is it for the given equation? Okay, we'll come to the questions. So this is how the topics, the weightage is spread among the different topics. Most important one is the motion under gravity. Okay, here we will be using those equations of kinematics in order to obtain whatever is asked in the question. Okay, so this is the topic wise weightage, you might want to note it. So with that being said, let's begin with the questions. So let's begin with the questions. Here in question 1, a particle moves along A, B, C, D. Okay, you are supposed to tell what is the magnitude of the displacement of the particle from A to D. Okay, magnitude of the displacement. Displacement is the shortest distance between the 2 points, right? So you connect A and D. So this is the distance over here. Okay, this is the displacement. Okay, if they had asked you for the distance, you'll have to go along the path, right? Here they have asked you for displacement. So it is the shortest path that connects point A and D. Okay, from A to D. So A and D. So here if you see this distance and BD distance, okay, those 2 distance we are concerned about, right? So this is 5 meters of course, and what will be this distance? This distance you can find using Pythagoras, right? So this is 5 root 2, so this will be root 2 times of that, right? You can do Pythagoras, you will get to the same answer. So root 2 times, so you will have 5 root 2, so this is root 2 times side, right? Basically using your square formula. So s root 2, right? So here BD distance will be 5 root 2 times root 2, right? Root 2 times s is your diagonal for the square, or you can use Pythagoras for this. You'll again get to the same answer, which is 5 2s are, now this is root 2 will be 2, so 5 2s are 10. So this distance BD is 10 meters and this is 5, so 10 plus 5 is 15, option D. Okay, that is the displacement. Okay, for the distance you'll have to go along the path. Okay, so 5 root 2, 5 root 2. Okay, so that will be this option. Okay, that is the distance. This is displacement, okay, between A and D. Let's come to this one. Here we have a car which is moving from X to Y. Okay, from X to Y. So initially it is going from X to Y with speed, uniform speed Vu, and on the return journey it is coming with a speed Vd. Okay, you are supposed to tell what is the average speed for this round trip. Okay, the average velocity would have been 0, right? Because the displacement is 0. Goes from X, comes back to X. So displacement is 0. So average velocity is 0, but average speed will not be 0. Okay, so if you see, some of you might know this directly because it covers equal distance, right, in with the same speed. Okay, so it is the harmonic mean 2v1 v2 upon v1 plus v2. Okay, but let's derive it. Okay, so average speed will be total distance, right? What is the formula for speed? Total distance upon total time taken, right? We know about the distance. We can assign some arbitrary value between x and y. This distance is supposed d. Okay, so the total distance traveled is d, right? 2d distance, right? So 2d distance is traveled. Time you can write as distance upon speed, right? Speed is equal to distance upon time, so time is equal to distance upon speed. Okay, so this is uniform motion, so you can use this equation, right? So total time, time is distance upon speed, so we'll break it in two times, right? t1 plus t2. One is going from x to y and then y to x. So t1 plus t2. Okay, so 2d. So t1 is, what is the distance? D, right? X to y is d, and what is the time taken? Okay, time is distance upon speed, right? So speed in that journey is vu plus now for the second return journey, we have again the distance is d, and the velocity while returning is vd, right? So vd, so you can see this d will cancel throughout, right? And you'll have 2 upon 1 by v1 plus 1 by v2, or 1 by vu by 1 by vd. Okay, this will go as product in the numerator, 2 vu vd, and we'll have vd plus vu, right? So 2 v1 v2 upon v1 plus v2, that is what I was saying, harmonic mean. Okay, so that is your average speed for this journey, and option A is the correct choice. Over to the next question. So question 3 and 4 over here. In question 3 we are asked, if a body travels some distance in a given interval of time, you are supposed to find the relation between average speed and average velocity, right? And you can clearly see that average speed will be always greater than or equal to average velocity, right? Because average speed is total distance upon time taken, whereas average velocity is total displacement upon time taken, right? So if you start from x and come back to x, the displacement will be 0, right? So average velocity will be 0, right? Average speed will not be 0. The distance will be d, 2d, right? So velocity comes from displacement, total displacement upon time taken, and displacement is always less than or equal to your distance, right? Because distance is the overall overall path length, right? So this distance has to be always greater than the displacement, right? Because if you take a step in the backward direction, the displacement will decrease, but the distance will not decrease. Okay, it's always the total path length, right? It will always increase. So average speed will be always greater than or equal to your average velocity, right? Because distance is always greater than your displacement, basically, right? So that is the reason. So let's come to this one. Here in question 4, we are given the position x as a function t, okay, of a particle. You are supposed to tell at what distance will the particle reverse its direction. So first of all, you can see this is negative coefficient of t square, right? So if you differentiate it twice, this 2 will come down first, then we'll have 10t, and then again if you differentiate, that 10 will remain, right? Minus 10 if you see, okay? So if you differentiate that twice, we will get minus 10, right? So negative acceleration, okay? So you can see that the object is experiencing negative acceleration. So first of all, it is moving in this direction, and the acceleration is, the force is in the opposite direction, okay? So the negative acceleration, okay, retardation. So after some time, its velocity will go on decreasing, and finally it will stop, okay? Velocity will become 0, and then it will change its direction, okay? You can see it from the very nature, okay? So the question is, when will the particle reverse its direction? So I told you the velocity will go on decreasing. At a certain point, it will become 0. That is the crucial point. That is the point where it is reversing its direction. So we have to find velocity and equate it to 0, right? You have the coordinate as a function of time, which is 20t minus 5t square. How do you get velocity? V is dx by dt. Simple, right? So you just differentiate it. So 20t, so that differentiation is 20, and 5t square differentiate, 2 will come down, 2 5s are 10t, and equate this to 0, right? Because we want when will the particle reverse. When the particle is reversing, the velocity has to become 0, at least at that instant, and later it will reverse, right? So you can solve this. 10t is equal to 20, so clearly you can see that at t is equal to 2 seconds, our velocity will become 0, or the particle will reverse its motion, right? At t is equal to 2 seconds. Okay, so basically you'll have to plug in t is equal to 2 seconds over here and find the distance at which this is reversing. Because t is equal to 2 seconds, velocity becoming 0, the particle is reversing its direction of motion, right? So the answer is in the form of x, right? So just substitute t is equal to 2 over here. So this is 40 and 2 is 5 4s are 20. Okay, so 40 minus 20 is 20 meters, which is option C, absolutely correct. Okay, so that is our correct choice. Over to the next question. So question 5 and 6 over here. In question 5 we are given a relation between time and the distance, okay, alpha beta constants. We are supposed to find the retardation meaning negative acceleration. Okay, so basically we can differentiate this twice and we'll get to acceleration, right? So acceleration will that will have a negative sign, so basically that sign is dropped and they have told it is retardation. It is basically negative acceleration. Okay, so first of all I am not going to directly differentiate it because we can see it's a quadratic equation, and if we differentiate we'll have x and v together. Okay, that is what I don't want. So I'll solve this quadratic equation. So I'll have x in terms of alpha, beta and t, right? So x will be, if you use the quadratic formula, minus b plus or minus under root of b square minus 4ac, 4a, and c is minus t, so plus t, and then we'll have 2 alpha, right, 2a. Now we have x in terms of alpha, beta and t purely, so we can use v is equal to dx by dt, and then we'll use again differentiate this to obtain acceleration, right? So here if we differentiate this is a constant, then we can differentiate this root of that, right? So 1 upon 2 alpha is there, so root of x differentiation is 1 upon 2 root of x, right? Root of x, the differentiation is 1 upon 2 root of x. So root of x is 1 upon 2 root of x. Now again differentiate this, chain rule, right? So beta square constant, differentiate this with respect to t, so 4 alpha, right? 4 alpha t differentiate with respect to t is 4 alpha. So 2 alpha and this 2 and 4 alpha gets cancelled, right? So we are left with 1 upon beta square plus 4 alpha t. This is our velocity. Okay, again differentiate it to get to acceleration. Okay, you can see that now we are getting that negative sign. Okay, so this is basically of the form x to the power n, right? N is minus half over here. You can see that this is square root and that will go in the numerator, so it is minus half. Okay, so I'll use this as differentiation, n x raised to n minus 1, right? So differentiate this, n is minus half, x is that bracket, right? So write it like this only, n is minus half, right? X raised to, so x is this whole thing raised to, so okay, x is this, right? We are taking that minus half as the n will. Okay, so n is minus half and minus 1, so that is minus 3 by 2, right? Minus half minus 1 minus 3 by 2, and finally again the chain rule we have to apply. Again go inside and differentiate this, so this will be 4 alpha, right? So we are left with, you can see, minus this and this can cancel, 2 alpha, okay, and this thing, okay, this thing you can see that it is somewhat like this, right? So you can write this as beta, so square root of, because raised to half it is there, and I can write the whole thing as cube, right? Beta square plus 4 alpha t cube, right? So this is nothing but this cube, okay, or v cube, okay, this, because this is this, right? So but there is also a cube, so this is minus 2 alpha v cube, right? Minus 2 alpha, and this is v, right? And there is a cube, okay? So minus 2 alpha v cube. So minus sign is dropped. We are told that it is retardation. So yeah, that is the value. Let's come to this one. Body starts to fall freely under gravity. The distance covered by it in the first, second and third second. Okay, it's the distance in the particular second, not over first second, then over 2 seconds, over 3 seconds. No. Okay, first second, second second, third second. Okay, what is the distance? So for that we have the informal equation. Sn is u plus a by 2 into 2n minus 1. Right? We refer to this as the fourth equation of motion. You might see it in H.C. Verma. This is the distance covered in the nth second. This is the formula for it. Okay. So you can also interestingly see that it may not hold dimensionally. Right? On the look of it, the equation is dimensionally incorrect. Okay, but still I am using it. Okay, it will give me correct answer. Why? Do let me know in the comment section. Okay, so S1 you can see that. So u is 0 basically, right? Falling freely. So you just dropped it. U is 0. Initially is 0. So n1 will give you. So basically this 2n minus 1 upon 2, that will generate odd numbers, right? You can see. So here you'll have a by 2, and when you put 1, it is 1, right? Then S2, if you want 2 to the 4 minus 1, 3, right? Odd numbers it will generate. So 1, 3, 5, right? 2 3s are 6 minus 1. So if you take the ratio, you will get this, right? 1 is to 3 is to 5. So option A. Okay. So if do let me know also what if this was distance over the second. Okay, distance in the first second, distance covered in the second, distance covered in the third second. In that case, which option would have been correct? Would it be the same one? Would it be different? Do let me know in the comment section. Okay. So over to the next question. So question 7 and 8 over here. In question 7, a ball is thrown vertically downwards, okay, from the top of a tower. Okay, it hits the ground after some time. So it is thrown down with a velocity of 20 meters per second. It hits the ground after some time. That time the velocity is 80 meters per second. Okay, or just before hitting, you can say. So what is the height of the tower? Okay, so this might have an easy approach, like going from your equations of motion, but you can also do it via conservation of energy. Okay, I am giving you one more tool, okay, to look at the things, especially in this chapter. Okay, you can use your conservation of energy, right? So if you see, initially the ball has some kinetic energy. Now the ball is at the top, right? It is thrown with certain initial velocity u, and it also has height h, right? So initially if you see, it has kinetic energy half mu square plus mgh, right? After some time it drops down and the velocity becomes 80, but it's just about to hit the ground, right? So h is 0 effectively, and the only energy will be kinetic, half mv square, right? So this m can cancel throughout basically. So basically you reach the same equation, right? V square is equal to u square plus 2as, right? If you see, but yeah, this is one more tool you can use while you are solving the questions of motion under gravity. Okay, so v square, final velocity is 80, so 80 into 80 by 2 is equal to u square, initial velocity is 20, 20 into 20 by 2 plus gh, right? G and h. So g, they have asked us to take it as 10, unless specified, use it as 9.8. Okay, so the options might not match. Okay, so be very careful. Only when g is specified as 10, use it as 10. Okay, h we are supposed to find. Now we can cancel this throughout. Okay, and this will give us 640. 640 half is 320, right? And this half, okay, this is 20, right? So this will be h. H is nothing but 320 minus 20, which is 300, right? 300 meters, which is option B. Okay, so you can either use v square plus u square is equal to plus v square is equal to u square plus 2gh, okay, or you can also use conservation of energy, okay, you will get to the answer. Let's come to this one. Here we have the displacement of the particle is given. You are supposed to tell initial velocity and acceleration. So basically initial velocity will be, you just differentiate it, right? So differentiate it. So a is a constant bt, so b will remain, then c 2ct minus 4dtq, right? And initial velocity, so you just have to plug in t is equal to 0, so you'll get b, right? B, so option C or this, okay. And what is the acceleration? You again have to differentiate this. So if you differentiate this, b will go 2c, you will get minus 12dt square, right? And again you'll put t is equal to 0 because it is initial velocity and initial acceleration, okay. So that will give you 2c, okay. So b is your initial velocity, 2c is your initial speed, which is option C, okay. B and 2c, okay, those are your correct choices. Over to the next question. Question 9 and 10 over here, the last two questions for the day, and let's kick it off. So question 9, we have a particle that starts from rest with some constant acceleration. It accelerates 25 meters per second in 5 seconds. Okay, so you are supposed to tell what will be the distance traveled in the next 2 seconds. Okay, so basically first of all you can find acceleration because there is some change in velocity beginning from rest goes to 20. So 20 minus 0 upon 5, right? So in 5 seconds, right? So that is 4 5s are 20, right? So this is the acceleration that we have, okay. This is useful because we want to find the displacement in the next 2 seconds. Okay, it's initially beginning with this velocity now, right? It's beginning with so initially it is at rest, right? It goes to 20 meters per second, right? Finally, so initially it is 0, then we get 20 meters per second in 5 seconds. Now from here to here in 2 seconds, suppose it is going to go. So what is this distance that it is going to travel in 2 seconds? Now remember that the initially, okay, starting it was 0, but now we are looking at this time frame, right? Here the initial velocity is not 0, okay, it is 20, okay, in the next 2 seconds. The question is framed that way, okay. What is the distance covered in the next 2 seconds? So beginning from here, okay. So after this 5 seconds, okay, beginning from here in the next 2 seconds, what is the distance covered? So it is now starting with a velocity of 20 meters per second, okay. So 20 and time is 2 seconds, okay. So here half acceleration we have found, it's constant acceleration, right? It's mentioned, so it will not change, of course. So 4 and t square again, which is 2 square, which is 4, and this is 40, and this will be 4 to the 8, right? So 48 meters, which is option B, right? So the only thing to keep in mind was the next 2 seconds, right? So next 2 seconds, so from here it is starting from here, so initially the velocity is 20, not 0, okay. Let's come to this one. Here we have been given the velocity time dependent equation for a body or a particle moving along x-axis at t is equal to 0, particle is at origin, the correct plot xt plot, okay. So first of all you can directly see that this is not starting at the origin, right? T is equal to 0, x not equal to 0, t is equal to 0, x not equal to 0, t is equal to 0, x not equal to 0, only this one is starting, right? So this is correct, okay. Or let's do it the way we are supposed to do it, okay. This is 20t, so this is velocity is given, we are supposed to find xt plot, right? So question from graphs, okay. So v is equal to dx by dt, so this is given to us, so I'll open it up. So 20 minus t by 10, okay. So now just integrate it for x, right? T, take t to the other side and integrate, right? So you'll get x is equal to 20 t, right? And if you integrate t, it will become t square, right? T square by 2, right? T square by 2, so t square by 20, okay. So if you see, this is like a inverted parabola, right? This is parabola, and t square what opens this, okay, so t square, right? So basically it is a parabola form, it won't be linear, and you can see that also at t is equal to 2, t is equal to 2, this is this going to be maximum, this will be 40, this will be something, okay. So it is not basically 0, okay, at t is equal to 0, at t is equal to 2, if you put, it is not 0, right? All other graphs it is showing 0, okay. So you can make a estimated guess. You can also see that also there is will be a constant c, that's why this condition is given, t is 0, x is 0, so that constant will turn out to be 0, okay. Yes, so you can see that at t is equal to 2 seconds it is not 0 only in this graph, that is correct, and it is also minus t square, right? X is related to t square, okay. So that is a unhappy parabola, minus t square, so sad parabola, okay. Happy parabola, x is equal to y square on space, okay. So that's about this question. I think D is the correct choice, yeah. So I hope you really enjoyed today's session. Do join me in the next one, and we'll keep this grind for BITSAT 2025 on, and let's crack it this time, okay. So I hope you really enjoyed this video. If you did, smash that like button. Do consider subscribing. More content for BITSAT 2025 coming up, and I'll see you soon in the next video. Till then, keep enjoying physics.